This video will cover the Singleton design pattern. If you aren't familiar with it, it's a technique you would use if you want to make sure you only ever have one instance of a particular object in your program. Why would you want to do that? You might want to use the Singleton pattern for classes that use an external resource where there might be a problem if multiple objects try to connect to that resource. For example, let's say a logging library, where every time you do something in your program, you want it to write to a log file. If you have hundreds of objects trying to write to the same file at the same time, you may run into a problem. One way to deal with that is to have a single object that manages all the file writing, so that way it can do it sequentially and not have a conflict. For example, if you don't use a singleton, your object A would have an instance of the logger object. Object B would have its own instance of a logger object, and object C would have its own instance. All three of these logger objects can try to write to the text file at the same time, and that may cause a problem. With the singleton, all of your objects use the same logger object, and it's the only one that tries to write to the log file, so it's easier to control writing to that file. Another option is to use a static class and a static method. However, with a static class, you can't easily mock it for any unit testing. With a singleton, it's easier to create a mock object that looks like it, so your unit test can work. For our example, we'll use this customer class. It has a private logger object that it instantiates by calling the getLogger method on the logger class. And this is a simple factory. You call this, it instantiates a new logger and returns it. But if we use this code, then we end up with multiple logger objects, which we don't want to have. So we'll convert this to a singleton. This first version is a bad version. You should not use it because it has problems that we'll talk about, but I want to show it to you so you know what it's like, because you're probably going to see it at some point. Here, our logger class has a private static variable, and when you call the getLogger method, it checks to see if the logger is null. If so, it creates a new one and then it returns it. This looks okay, but this has a problem if your program is multi-threaded, because it's possible that two objects may come through the getLogger method at the same time. They both may see the logger variable when it's null, and they both may try to create a new instance of the logger object. If you're using a method like this, there is a safe double lock method that does not have a problem when multiple threads are running. And here's the code for that one. We have our private static logger variable, and we have a new read-only static variable that's called synclock, and it's just an object. Now when your other class is called the getLogger method, what will happen is one of them will always be first. Even if you have 100 objects calling getLogger at the same time, one's still first. So it will come through here, see that logger is null, and the first one locks this synclock variable. It just kind of says, I own this. And only one object at a time can lock that. So it will continue on, check again to see if logger is still null, and if so, create a new instance of a logger variable and assign it. Then when it gets to here, the closing curly brace for the lock, it releases the lock. And now the next object that was waiting behind at this lock can come through. It's going to come through, check the logger a second time, see that this time it has a value, so it won't try to create a new one, and it will end up returning the one that was created by the first thread. This is a thread-safe way of doing a singleton. Notice that we also have a volatile keyword up here for our logger object. That's a way that the .NET framework ensures each thread gets the most recent updated version of this logger variable. And the synclock variable we're using, there's nothing special about it. We just need one thing that the lock can try to hold on to, so the other threads know that something is in process and they need to wait. Now with the .NET framework, there's an even simpler method of doing this. This is called the static initializer method for the singleton. And here we have our private static variable, and we instantiate a new logger object here. So when our other classes call this getLogger method, it's just going to return this variable. The .NET framework is designed so that this will be guaranteed to be created. That isn't true for every language and every framework, so you can't always use this method. But if you're doing C#, you can. and it's a lot simpler than writing extra locks and having your extra lock variable. In the real world, you don't use a singleton very often. If you do, it's normally because you're writing to a text file and you want to make sure you don't have any conflicts there, or if you're using some other resource that might have problems with hundreds of objects trying to connect to it at the same time. One time that I've used this was with a web service that received orders, translated them, and submitted the orders to different programs. We couldn't be sure how many connections the other programs could handle from our application, so we created a singleton object with a queue. Our programs would put orders onto the queue of the single object, and then that class would submit our orders one at a time to the other applications. That way, we didn't need to worry about how robust their applications were. If you have any questions about this design pattern or other ones that you would like to see, please leave a comment below. Thanks.